Hello world, microcats! Do you know Morse code? No? When we assemble the keyboard, microcontroller and display into a circuit for encoding and decoding Morse codes. Here are the test short strings: ABC, SOS, hello, button 4 clears the screen, and so all characters in Morse code are encoded with 2 bits, a dot and a dash, as well as a set of pauses. By programming this table into a microcontroller, you can get the Morse signal from your character string. Let's see how it all looks on the oscilloscope screen. We see the encoding by letter, and the letters are separated by pauses. The controller does 2 things. The first synthesizes Morse data from user-defined text. The second decodes the received data and displays it on the screen. Hello, did not fit. The original idea of a video was to do a transmission and reception of these microcircuits. This is a transmitter, plus, minus and controls. This is the receiver, plus, minus and 2-pin control. They are both powered from 5 volts. The receiver has a small frequency adjustment. The transmitter was planned to be controlled from such a homemade key. The key is made from building materials. These are plasterboard hangers, iron plates, PCB stands and plastic parts for isolating closing contacts. It looks crazy. We look at the oscilloscope what happens at the output of the receiver. The transmitter is still disabled. After turning on the power, we see such short bursts. That is, the receiver gives out false signals. We also connect the LED to the output of the receiver and also power the transmitter. We see the response of the LED to burst from the receiver. These are the very hindrances. Let's connect the key to the transmitter. Plus 3 volts power is supplied through the key to the transmitter input. We see that when the key is pressed, the signal from the transmitter comes to the receiver and the LED lights up brightly. The oscilloscope has a high signal level. Theoretically it works, but we see that when turned on, the high level decreases for a short time. These are the bottom short bursts. We get that the receiver always emits short high signals, the LED blinks weakly, and when the transmitter is turned on, the edges rattle very much. Let's change the scan and take a closer look. We see that the fronts are protracted and there is a large amount of interference. In addition, bursts occur when the key is pressed. And this is what the Morse signal generated by the microcontroller looks like. Practice has shown that the hardware cannot properly filter out such a noisy signal, so the radio transmission will be in the next video with other modules. In the meantime, let's look at the electrical part. The brain of the entire system is the STM32 microcontroller. Data indication is assigned to the display. The control goes through the touch keyboard. Unsuccessful solution for radio modules: telegraph key, transmitter and receiver. Everything is powered by a 5 volts pulse converter. Let's move on to programming. The software part has undergone a lot of revision. All peripheral configuration is located in the microlib.c file. Work with the display goes through the structure object. We indicate the pins used, the SPI interface. This is a special macro for working with input-output pins. We initialize the display and display background information. In an endless loop, we check the flags that are responsible for working with the keyboard. After pressing the keyboard button, we call the function preparing for receiving Morse data. We call the function of synthesizing Morse data and sending them to the outgoing port. We receive decrypted data from the incoming port, and we display them on the screen. The prepare function resets the required variables to their default values and turns on timer 4. The send function from the incoming character string makes them character by character breakdown. The words are separated by pauses. Each character is decrypted into Morse code, and dots or dashes are sent to the outgoing port in accordance with their duration. A pause is made after each character. The function of searching for a symbol in a table returns the index of the symbol. The function of searching for a character by its Morse encoding returns the character itself. The function of receiving Morse data simply copies the decrypted values to the user buffer. Timer for interrupt for 4 events. Event 1 is the capture of the leading edge of the signal. Event 2 is the trapping of the trailing edge of the signal. Event 3, also known as update interrupt. Event 4 is an incoming trigger. When capturing the edges, we accumulate the value of a capture register in the array, taking into account the overflow counter. Analysis function calculates point duration on the fly. We do the same on the trailing edge. The update event additionally calls the line idle analysis function. An inbound trigger event resets the overflow counter. For timer 4, the external clock rates are calculated and values for the prescaler and period are set. In this case, 0.1 milliseconds is the duration of a single tick, and 1 second is the duration of a period. The timer is configured in PWM capture mode. The incoming flip-flop resets the counting register when the rising edge of the signal appears. Do not forget about interrupts. We enable 4 events for timer 4. The analysis function allows indirectly calculate the duration of a point through the duration of a pause between bits. Ideally, they are the same. The dot settings function analyzes the duration of a logical unit and decodes it into a dot or dash. The pause function analyzes the duration of a logical zero and decodes it during a pause. The idle line analysis function detects the absence of a signal on the line. In the line is idle when the decoding of the duration of logical 0 and 1 into an array of Morse bits from dots, dashes and pauses begins. Further, this array is transformed into character data, and at the end turn off the timer. In an infinite loop we observe the order of calling function. First, preparing and starting the timer when issuing a Morse signal, when receiving the captured data and transforming it back into symbolic form. That's all, see you in the next video. Subscribe, Microcat.